So what does all this mean? Well, let's say we've got a function over here, which we're going to call f. And so you can see that the graph of f is this nice black line in here. Now what we might want to do is find the area underneath the curve of the function. Okay, so underneath, and also above the x-axis, which is right here. Okay. Now how are we going to do that? How are we going to estimate that? So here's what we're going to do. We're going to take and we're going to get what we call an upper estimate, which is here in figure 6. You can find the same figure in your textbook. And so figure 6 here, what we've done is we've divided the x-axis, or partitioned it, okay, into these little sections. And then what we've done is we've said, okay, let's take the function at the highest point over that interval. So what we're going to do is we're going to divide it, and then we're going to say, okay, where's the function the highest? Well, the function's the highest over here. So what we'll do is we'll use that height, and we'll use this as the base, and we'll call this A1. So what I want is the area in A1. And that's not that hard to find. All we have to do is calculate what's the function, and then how far did we move on the base here. And we're going to do the same thing here with this next rectangle. We're going to take that area, that division here, partition, and we're going to see where's the function at its highest along that interval, and it's up over here. And so we're going to draw our line over from there, and this whole area, okay, that's area 2, this was area 1. Now you can tell so far that we've got an overestimate. Okay, so we want the area in A1, A2, and then also we're going to do the same thing over here in A3. Again, we're taking this x interval down here, okay, this guy right here, and we're seeing where's the function the highest on that interval. Well, it's the highest up here. So what we're going to do is we're going to take that height, okay, which is here, it's this height, multiplied by the base value, and that'll give us area 3. And if we take area 1, add it to area 2, and add it to area 3, we get a total area. And that area is an overestimate. Okay, so clearly it's an overestimate of the true area that lies underneath the curve and above the axis. So here, if I draw on my function and I calculate all this area, you can tell that the purple area, because it captures this piece, and these two pieces right here, the purple area overestimates the red area. Now here in figure 7, the same thing. Okay, we're going to do the exact same problem, but here we're going to underestimate. So we're going to take the axis and we're going to divide it up into the same equal intervals that we just did up above in figure 6. And so then what we're going to do is we're going to say, okay, along this interval right here, what is the function, what is its minimum? Well, the minimum value occurs here. So we'll use that as the height for our box, and we'll grab the area. So this is going to be A1. Again, we'll take a look over this interval right here. We'll say when is the function at its lowest. So we'll grab this height. Okay, that's A2. And then, of course, on this interval, we'll grab the function's height at its lowest, which is here. and that'll be A3. So here A1 plus A2 plus A3, it gives us again a total area, and that is an underestimate. Okay, of the actual area, of the true area. Again, if you notice, what have I missed? Okay, well, I missed this area right here. I missed this. I missed all of this area here. And I missed that area there. Okay, so again, the difference between these up top here and these down here is that up top we got an overestimate because we always took the highest point of the function. On the bottom we got an underestimate. Now both of those, again, give us estimates, but they don't give us the actual value. So here's what we're going to do next. We're going to go ahead and we're going to grab, instead of subdividing this into, let's say, 3, let's subdivide it further. So here in figures 8 and 9, again, we have that same curve, and we want to estimate the area. And so we've subdivided the x-axis into little intervals. So here's one interval, here's a second interval, a third, fourth, fifth, sixth, seventh, and an eighth. And notice that the intervals aren't all equal to one another. Okay, and this is fine, there's no problem with that. Okay, we're just trying to get an estimate for the area underneath. Again, the same division of intervals down here. And what I want to point out is that the top one's an overestimate. So if you look, if I take this block right here to estimate the area under the curve, okay, the true area, which we'll put here in orange, this is the true area, but the green adds this little bit extra up here. So we have an overestimate. Down here, we use the lowest point, okay, and we get an underestimate. Why? Because we're missing this little area underneath the curve. So here, the green is an underestimate of what we actually want. But the thing here to note is that I put more rectangles underneath. So for this guy up top here, the overestimate, I'll fill it in, it's still there and it still exists, right? But it's just not a ton of area compared to the last problem. Down here, the underestimate, okay, so we lost out, we didn't calculate these areas right here, and we should have, but that's alright, because those orange areas are the error amount, the amount that we're off. So the idea that you should pick up here is the more rectangles used, the better the estimate.